Hello everyone, welcome back to my YouTube channel CSN IT Tutorials by Vrushali. In our previous some sessions, we have discussed about all the important topics of DSA with practical demonstration, solve examples and important question bank. I have attached a complete DSA playlist link in below description box. I have also covered a complete topics regarding database management system, operating system, SQL, then computer network, software engineering, then HCI, machine learning and processor architecture subject. You can refer this playlist for your exam point of view. Please share my channel with your friends and subscribe it. That will be beneficial for everyone. Now, in today's session, we will focus on our Prim's algorithm implementation. We have already discussed solve example of Prim's algorithm in detail in our previous video. So please refer this video to find out how to solve the examples stepwise. See here, so this is a complete Python implementation of Prim's algorithm. So here, program always start with the adjacency matrix. See, this is your given graph. Your graph always be represented by the adjacency matrix. See here, each number represent the distance between the 2 points. 0 means there is no any direct path present between the 2 vertices. Now let's understand first this graph in detail. Just a second. Okay, see here, this is your given graph in your program. So this graph represented in this particular way in adjacency matrix. So there are total 4 vertices. That is 4 by 4 matrix is there. That is 0 to 3 vertices are present. So total vertices are 4. Now see here, 0 to 0, that will be a self loop. So there is no any self loop is present. So that is 0, means there is no any direct path between the particular vertex. Then 0 to 1, see, 0 to 1 and h weight is 4. Prim's algorithm always works on the undirected graph. Then 0 to 2 weight is 6. See here, 0 to 2 weight is 6. Then 0 to 3 weight is 0. So 0 to 3 there is no any direct path. So the weight is 0. So in this way, by using this matrix, this particular graph have generated. Now you have to find out the minimum spanning tree. Means you have to find out the shortest path between all these vertices by using Prim's algorithm. So how to find? See, you need to first visit vertex 0. So this is your starting point or source vertex. Now from 0, which one is the minimum edge? The weight of this edge is 6 and weight of this edge is 4. So which one is minimum? 4. Means after 0, you have to visit vertex 1 and the distance between this 4. Now you have to visit 2 vertices 0 and 1. So in next step, you have to find out the shortest path from 0 and 1. See here, from 0 there is only one edge, weight is 6, and from 1 there are 2 edges. First edge weight is 3 and another edge weight is 6. So which one is minimum? 3, right? So next time you have to visit vertex 3 with edge weight is 3. Now you have to visit 3 vertex 0, 1 and 3. Now you have to find out the shortest path from all these 3 vertices. See, now from 0 only one edge, that is 6 weight. From 1 only one edge, weight is 6, and from 3 only one edge, weight is 2. So which one is minimum? 2. Now next time you have to visit vertex 2 and edge is 2. See here, so this is called as minimum spanning tree. There is no any cycle is formed. You have to visit all the vertices to find out the shortest path. Now you have to implement same concept by using Python implementation. So see here, just a second. Okay, see, so this is your given graph, right? Adjacency matrix of your given graph. So number of vertices are 4, means in your graph total vertex are 4. So for that purpose we are using one variable here and the variable name is num vertices. After that, just focus on this two line. So selected. Selected is represent a list or array in particular Python. So selected array keep track of which vertices are already part of our minimum spanning tree. Initially, you can't visit any particular node. So initially it is false. At the beginning, you have to visit the vertex 0. 0 is your starting point, source point. So they indicate selected of 0 equal to true. So true means you have to visit that vertex and 0 is included in your minimum spanning tree. So selected of 0 equal to true. That is your first vertex. Now after that there is a print statement. So this is just a print statement. It is a heading of our output table. In your output table there are total 2 columns. First is age, another one is weight. So they find out the shortest ages according the weight. Now next one is the for loop. So this for loop indicate you have to find out the shortest path repeatedly, right? So for that purpose we are using the range keyword in Python. Range keyword indicate the start and stop of particular graph. So initially we are starting the shortest path from the 0, right? So there are total 4 vertex. So 4 minus 1, 3 means 0 to 3, 0, 1, 2 and 3. So you have to find out the shortest path repeatedly from these 4 vertices. So that's why range keyword is there. Now minimum equal to 9999. So minimum act like a infinity. We are assuming that all the edges weight in graph will be smaller than this. So during each step of Prim's algorithm, we compare all edges. And if we find a edge with minimum weight, minimum distance or smaller than this value, so we are updating in minimum spanning tree. Now again there are total 2 variables x and y. So x indicate the source vertex, starting point, and y indicate the destination vertex, that is ending point. If you find out the smallest edge between 0 to 2, that is 4. So 0 is your x and 2 is your y. So x and y, starting point and ending point. So after that, see here again there is one for loop. So this for loop check that all the vertices that are already included in minimum spanning tree. See here. So again range keyword is used. Number of vertices are 4, that is 0 to 3. So if you selected your first vertex, for example 0, then you have to find out the minimum weight. Either it is from 0 to 1 or 0 to 2. Suppose minimum weight is present between 0 to 1. So 1 is indicated by the j variable, right? So here j is indicate that you have to select that particular vertex, okay? And this vertex is not included in minimum spanning tree, right? So j is another vertex which is not selected 8, and the weight between I to j is not equal to 0, right? Suppose 0 means no direct path, but not equal to 0 means direct path is present between I to j with minimum weight. So here if we find smaller edge than our minimum value, so we are updating x to y weight, right? So after checking all the edges continuously, repeatedly, so we print the smallest edge that we found. So we mark as vertex y, that is your selected, right? X to y, y is your next visited vertex. So we mention at selected of y equal to true. So in this way we are finding the shortest path between all the other vertices. So result of minimum spanning tree is to find out the shortest possible path between the total connection of nodes. So let's execute this program once. See here. So this is your print statement, right? Age and weight. Now according to our example, see 0 to 1, this is your first selected shortest path. 0 to 1 is 4. See here, 0 to 1 is 4. Now from 1 again you have to find out the minimum weight. So from 1 to 3 weight is 3, and 3 to 2 weight is 2. See here, 1 to 3 weight is 3 and 3 to 2 is weight is 2. So they find out the shortest path from all the other vertices. So in this way, you have to execute this program and prepare accordingly. Thank you. Keep learning.